August 30th, 2025. At exactly 7 a.m., Flamingo missiles launched from Ukraine's Odessa coast are rapidly advancing toward their targets in Crimea. These bulky missiles plunged toward the heart of Russian defenses. It was as if they were waiting to be hit by S-400s. 3 Flamingo missiles were easy targets, but they had been fired directly during daylight hours. At that moment, Russian generals were planning a new attack via Crimea and had interpreted Ukraine's preparations as defensive. Ukraine was actually counting on this. The moment of attack is actually the weakest moment and creates gaps in defense. 3 Flamingo missiles, each weighing 7 tons, with a range of 3,000 kilometers and capable of carrying a 1,150-kilogram warhead, were transported to the launch site. Flamingo missiles were in plain sight for the first time for a rational attack. As these missiles were being transported to the ramp, the S-400s protecting Crimea's airspace were actively on duty. Therefore, it was not an easy task for the Flamingo missiles to hit their targets and for the mission to succeed. Kiev took all the risks because today, a small variable would be added to the picture. A millisecond delay in tracking and an incorrect priority list. Russian generals thought this was just a defensive anomaly. The Ukrainian plan was waiting for precisely this moment. First, a silent curtain would fall, then a fat shadow would glide low. Preparing these missiles for launch was a lengthy process. During this time, other military elements to be used in the operation had already been activated. In addition to the missiles, the UJ-26 long-range kamikaze drones were another key component of the attack. At the start of the operation, around 7 a.m., there was a flurry of activity at the Russian Secret Service building in Armyansk. Russian commanders and intelligence officers were involved in planning drone attacks on southern Ukrainian towns. Additionally, helicopter apron traffic was about to open on the Simferopol axis. The Russian patrol plan along the Sevastopol coastal security line was locked in for the morning shift. The Russian army was likely preparing for a mass, simultaneous attack via Crimea. However, a few minutes later, an inconsistency would be seen in the regional air picture of the Crimean Peninsula. First small, then rapidly growing. UJ-26 drones and 3 Flamingo missiles. This attack combo would shock Russian intelligence officers and elements of Russia's Black Sea Fleet. In the first stage, the drones were sent towards Crimean airspace. The UJ-26 drones were expected to reach Crimea in approximately 45 to 50 minutes of flight time. About half an hour after these drones were sent, 3 Flamingo missiles were fired. The time for these missiles to reach their target was calculated to be approximately 15 minutes. In other words, both the drones and the missiles would create tension in Crimean airspace at the same time, and the targets would be hit by these elements simultaneously. As the drones began to approach Crimea, 3 Flamingo missiles were fired at 5-second intervals. Each missile switched to a terrain-following profile parallel to the coastline at low altitude. The flight altimeter, inertial navigation, and GNSS were tripled for redundancy. In the event of GNSS loss, the radar altimeter and digital terrain reference were prioritized. The missile speeds remained low. The goal was to approach at a subsonic speed of 950 kilometers per hour, below the radar horizon, without being detected for a long time. The warhead mass and range of the Flamingo missiles facilitate tactical design. The 1,150-kilogram warhead exceeds the threshold for structural collapse or functional paralysis in a single strike, producing a combination of pressure and destruction in underground spaces with a bunker-busting delayed fuse. This scale corresponds to more than twice the explosive mass of a Tomahawk. Therefore, when these missiles hit Russian military bases, only explosion and destruction could occur. The 3,000-kilometer range would provide extensive flexibility in route planning. Furthermore, the Flamingo, manufactured with a fiberglass composite body, was designed to withstand Russian electronic warfare systems. In this mission, the targets were close range, but the variety of approach vectors afforded by the range and the uncertainty of the launch location would have complicated Russian defense planning. The initial impact in the attack operation came from drones. Low-profile kamikaze UAVs entered at low altitude from the northwest and northeast of Crimea. Each UJ-26 drone carried a high-explosive payload in the 25 to 30-kilogram class. Due to their composite body and small radar cross-section, they left only 1 or 2 cells per scan on fixed antennas, providing point-of-impact geometry to the power distribution cabinet, waveguide, and field fiber centers with optical infrared sensor pairing. The drone speeds were between 150 and 180 kilometers per hour, with flight control via GNSS plus INS and backup optical reference. The range parameter was maintained between 200 and 400 kilometers depending on the target, which was sufficient to reach the terminal via inertial navigation even when exposed to electronic jamming. Blinding strikes add delay to the signal processing chain, reducing the lead time window to seconds. This meant Russian air defenses had very little time to intercept without error. However, Ukrainian drones were rapidly approaching targets to completely eliminate this intercept window. The first blinding strike hit the power distribution cabinet of the 96L6AP detection radar. The explosion did not knock out the antenna, but it increased the delay threshold within the power supply and signal processing chain. This created a line present, no identity effect on the screen and extended the operator's recognition classification cycle. A few minutes later, the waveguide of the MR-10M1 coastal surveillance unit broke. The antenna continued to rotate, but the signal-carrying vessel was severed. In a densely layered network such as Crimea, 100% blackout is not practical. The real value is to impose a few minutes of delay on the reaction chain. The Pantsir/Tor batteries in the lower layer reacted reflexively. 2 kamikaze UAVs were shot down. However, the other 4 reached their target cabins, and this scattered attack created an intermediate situation that appeared to be working in the radar communication network but did not produce any meaningful traces. The 25 to 30 kilogram HE payload targeted the main power supply elements rather than knocking down the antenna. This move would delay the defense's lock-on to the strike missile by seconds, and that delay would create an opportunity for a missile with a low-altitude flight profile. It was precisely at this point that the strike wave was planned to be launched, because even if the defense fired, the tracking delay and radar horizon limitation could not prevent a missile with a low-altitude flight profile from infiltrating. Now it was time for 2 Flamingo missiles to target the Russian FSB building in Armyansk and for 1 Flamingo to level Sevastopol. There was another major risk for Ukraine was GNSS jamming. Therefore, the Flamingo route was backed up with GNSS-INS altimeter digital terrain reference. Flamingo 1's target was the command and communications room inside the border security and intelligence base. The warhead was a delayed fuse penetrator HE composition. This setting produces an explosion inside the volume after passing through the outer shell. The bunker buster derivative keeps the delay at the millisecond level in thick masses, amplifying the shock wave inside the room. The goal is not to destroy the building from the outside, but to kill its function. Power distribution, network backbone, rack systems, cable trays, infrastructure hubs. Flamingo 1 entered the target coordinates. Altitude was stabilized between 20 and 25 meters. The strike finally occurred. The outer concrete shell of the FSB building remained standing. With a half-second delay, the internal explosion severed the energy backbone. The terminals in the command room lit up, but the network was silent. Field radio bridges went down. The operational meaning was clear. There is light, but no data. For the defender, this is even riskier than a total blackout, because the decision-maker wastes time with the wrong screen. While this crisis environment continued inside the FSB building, Flamingo 2 locked onto the fault between the power distribution line management point and the field communications cabin in the same complex. The header was again delayed. The goal was to create a loss of function that would extend the repair cycle from days to weeks. A brief GNSS interference was observed 15 kilometers from the terminal. The missile remained autonomous, with altimeter INS and digital terrain reference. When the signal returned, the error bucket was reset. Meanwhile, the defense launched another interception via Pantsir. Due to low altitude and city reflections, no solution could be found for a frontal intercept. Although the base appeared to be administratively intact after all these Flamingo missile attacks, its command control function was completely lost. The Ukrainian side then moved on to the next phase of the operation. Flamingo 3 entered the final stretch towards Sevastopol. The target was a small pier where patrol boats were moored. The 2 strike points selected were the fuel supply manifold and the small command cabin at the pier. So why were these 2 points targeted? Because if these lines are severed, even a solid pier block becomes inoperable. Boats cannot dock, the fuel cycle is interrupted, and diver and barrier operations are delayed. This means the harbor entrance is deemed unsafe. Flamingo 3 stabilized at an altitude of 15 to 20 meters at the terminal. The warhead was set to detonate internally. At the moment of impact, the fuel line ruptured and the cabin disintegrated. The mooring piles were dislodged. At least one hovercraft-class patrol boat suffered heavy damage after losing its mooring connection. The damaged vessel was identified as an A-8 Kivas, or A-25 PS hovercraft, designed to carry 8 or 25 armed soldiers or Marines. For the others, the connection and fuel cycle were interrupted. On the port side, the quay surface had collapsed, and the fuel line was severed. Defensive fire continued, but there were no missiles left to fire. The window of opportunity for attack closed. Because the reaction was delayed, none of the countermeasures provided any significant damage reduction. In other words, Russia suffered the shock of Flamingo missiles and kamikaze drones in Crimea. So why couldn't Russia prevent this attack targeting the FSB building in Crimea and the hovercraft in Sevastopol? The S-400s were not weak. On the contrary, they had the potential to shoot down all cruise missiles simultaneously. However, Ukrainian sources reported that none of the missiles were shot down. The situation that facilitated the operation was low altitude. That is, we are talking about 20 to 30 meters high. The radar horizon is a fixed area. A low-flying target can only be seen by a fixed antenna when the target radar line of sight is converted due to ground curvature. At an altitude of 30 meters, this distance is approximately 20 to 25 kilometers. So when the radar sees it, the target is almost overhead. If front intersection cannot be calculated in this window, the backchase scenario is used. The particle-headed interception cloud spreads behind the target. Flamingo's low altitude and constant speed profile produces a slow plus small RCS-like appearance in the radar's Doppler filter. Coastal reflections also cause false tracks. The result is that the lock is broken and interception is missed. This does not mean that the S-400 is weak. The combination of geometry plus timing renders this Russian air defense system ineffective in a short window. But this mission was a difficult threshold. As mentioned, it would be a mistake to underestimate the S-400. Success depended on producing a delay of a few tens of seconds and turning the low-altitude geometry to the attacker's advantage. Flamingos kept deep bunker targets at the single-shot threshold with their fat warheads. UJ-26 operators did not miss the millisecond window. Kamikaze UAVs produced dilution rather than total blackout here. Blinding was kept at the threshold, and the missiles affected 3 targets in the same minute with time-on-target discipline. This created a load distribution that prevented the defense from focusing on a single target. The difficulties on the ground and the margin for error should not be overlooked. The probability of the attack succeeding was actually much higher than the probability of failure. 2 kamikaze UAVs were shot down. One wave was delayed, and the 96L6AP showed instant recovery. The Tor battery fired 2 interceptors at Flamingo 1. If the lock-on scan had gained continuity, a real risk could have arisen in the forward intersection window. GNSS jamming could have caused the strike to miss the target by tens of meters if there was no altimeter digital terrain reference at the terminal. This would have meant an explosion outside the target. None of these were left as assumptions. The route and terminal were backed up. The target set was distributed according to the 2 critical points rule instead of a single large piece. Ultimately, no chain of errors occurred, and all 3 Flamingo missiles found their targets. The final damage effect assessment after the operation was quite critical. The FSB border base has no command control function. The power distribution backbone is severed, and the field communications cabin is burned. This means that even if the base's administrative building remains standing, it cannot produce command and supply coordination for the units in the field. The Sevastopol pierhead has collapsed, the fuel line has been severed, at least 1 patrol boat is out of service, and the refueling cycle for the others has been interrupted. The fact that 3 Flamingos produced results on this scale for the first time showed that even a layered shield, when combined with the warhead mass and low-altitude profile, can be forced to produce gaps measured in minutes. What follows depends on reorganizing the sensor nodes with redundant power signal fiber plans and deploying mobile capture antennas for low-altitude intersection geometry. But until that system is in place, the gaps left by this morning's 3 strikes will continue to be felt on the calendar. Thank you for watching.